This was a shipped-in Pioneer AV receiver that cost the owner a small fortune to get it to me due to a mess up in the paperwork, which resulted in a bunch of taxes being assessed when it crossed the border. This time I have a Pioneer VSX-D1S, looks like. And the complaint on this is that it's in protection. The speaker relay will not kick in. So let's plug it in and see what it does. Got this one plugged into our big dim bulb tester. When I turn it on, draws a whack of current initially as the capacitors charge up. And sure enough, don't hear any clicks. The speaker relay is not engaging. So let's remove the top cover. Now this is just a Dolby surround receiver, not a Dolby Digital. It doesn't have any HDMI inputs or outputs on it. It's just got composite and S video. And of course a phono preamp. And these ones are actually quite serviceable because, believe it or not, they built them right. They have an access panel on the bottom so that if you need to get to the bottom of the circuit board, you can do so without having to tear the entire unit apart. Unlike a certain Yamaha that I was quite critical on the other day because of its lack of serviceability. So here's the inner workings of this unit. My bird is back. You can hear him out in a tree. For those that don't know, that's a bald eagle. So let's give this unit first a quick visual inspection and see if we see anything obvious that's wrong with it, such as broken solder connections on certain driver ICs. First area of concern on any of these amplifiers is broken solder connections on things like driver ICs, which this has on it. These ICs are what drive the output transistors, and sometimes we'll even see, look at the connection, see this? So there's a good chance that this is where our fault is on these driver ICs. So before I go any further, because I know it's not operating, the relay is not kicking in, we're going to just resolder these connections on both of these driver ICs to begin with. There'll be more than that. There'll be some more on other boards as well, I think. I'm just kind of trying to take a peek and see where everything is on here. This is one set of outputs here, and there's another set of outputs there, and there's another set of outputs down at the back or bottom here. So they'll have like a center channel. This is probably the center channel here. This is either the front or the rear channel, and then the main channel down below, more than likely. But any of these, like any of these circuits that we have a bad connection, it's going to cause an incorrect bias on the outputs, and that will cause the unit to stay in protection mode. So we'll turn on the power supply for the soldering iron. I'll show you what I'm using now for this soldering iron, because I've been using these little secure irons. So if you guys remember, a number of years ago I built this power supply. I sent this little module from Banggood, and it's a power supply that you can regulate the current and regulate the voltage and set it whatever, and set it for whatever you want. In this case, my input voltage is 37 volts from the transformer, which means I can set this thing up to 37 volts. And I can have it up to, I think it's 5 amps, something like that. Anyway, it gives me a readout of how many watts and everything is being drawn. So I'm using it with these secure irons I've got. This is the new one. This is the old one. The difference between the two of them is the tip it takes. This one takes the longer, I think it's the T12 tip, and the other one takes the shorter tip. This one can take both. This is the one that I reviewed last week, where it actually has the screws, so you can move these contacts up here for using it on a shorter iron. But I've got one for the shorter iron, so I just use this one. Both of them are excellent. I've been finding this has been a great iron. And watch how quick. Ooh, I'll show you when I heat it up. Watch the wattage. Watch the amperage, the wattage, and how fast this thing gets the temperature when I turn it on. So we'll click it on, and there it goes. Okay, 58 watts. As you can see, the iron gets up to temperature very quickly. I'm at 700 degrees now. We're ready to start working on this unit. But for starters, let's redo the connections on these drive ICs. Jeez, that didn't flow as well as I would have expected. Oops, got a bit of a bridge there. We'll just clear that out before we go too much further. Resolder the output transistors as well while I'm at it. At this point I can plug the unit in and we'll see whether the relay will kick in. Again, we'll plug it into the limited load light bulb. And that way, if there's any problem, we won't make it worse. I still don't hear a relay clicking. Oh, wait a minute. I just heard a relay click. Could I have fixed it? Let's hook up some speakers. That may have been the problem right there. So let me hook up some speakers. This time we'll put it on full power. This one will be safe to turn on full power. I'm still plugged into my light bulb. As you'll see when I turn it on, we get the inrush, but not drawing excessive current. At this point I can flick the switch on, give it full power, and make sure that the volume's not turned up all the way. Let's gotta figure out how this thing works. Oh, one of the speaker switches is kind of foobarred on the front here. May have been damaged in shipping. But let's see if I can get it to switch to tuner and set it to a radio station. Okay, that's how that works. As you can see, the speaker B button has been pushed in. Speaker A looks like it's on. Let's dial in. Okay, this time I didn't hear the relay click in, but I did before. So we'll investigate a little more. I also got to investigate that speaker switch on the front because the B button is kind of out of position. So let's investigate that, and I'm just going to pull the bottom off it and look for some connections on the bottom as well. Just looking at some of these regulator boards. I think these are the regulator driver transistors. But we're going to redo those as well. While I'm at it, before I pull the bottom off, let's just reflow those ones. This unit has a nice hatch on the bottom for easy access. Let's pull the bottom and do an inspection. On the bottom there's more evidence that there's a few connections that are dry, such as on these driver transistors. And up here we're going to redo those. And then we'll try firing it up again and see whether we get any different results. Take care of all the obvious dry solder connections first before starting to look for components. It is generally the best way when you're servicing these. Okay, now we're going to bring out the meter and see if we get any DC voltage where we shouldn't. In other words, on the emitter of any of the output transistors. We will have power, obviously, on the collector, but we don't want to see power on the emitter when we do on this one. We got minus 59 volts, minus 60, minus 57, minus 67, minus 57, minus 57. Look at that. We've got no positive voltage. So we have a problem in the positive power supply. Now this could be a burned resistor, but let's just see if we've got any positive supply on any of the output transistors. Okay, so I hate these leads. They get tangled up all the time. We have a negative supply. We have a positive supply there. Positive supply there. Negative supply there. So that one's good. Positive supply. Negative supply, but on the main board, I don't see a positive supply. Let's find out why. Remember, this is a push-pull amplifier, so we should have a positive supply on one of these two transistors. We aren't seeing any positive supply at all. So somewhere along the line, we've lost our positive supply. This unit has two power supplies, a 38 and a 65 volt. It's the 65 that the positive has gone bad on. Power supply comes in from the bottom down here somewhere. I'm just looking for any place that I've got there. I've got 12 volts there. I got 5 volts. We do have a positive supply on the board there. Where's our main source coming in for our plus 50 volts? Minus 60. It's going to be probably a resistor that's open. Minus 60. The positive filter is this one. This is the negative filter. We know that because if I put my probe on ground and put it on the top of the capacitor, we can see there's a negative charge. Minus 39 volts. It's unplugged, so the capacitor is just charging. So this will be the positive one. This side is grounded. Positive terminal. If this one is also grounded, that's the negative. This is the positive supply. The positive terminal is going to be on this side, and there's a good chance that either the board is fractured or something down here. There's a damage on the board. We've lost our positive voltage somewhere between here and the outputs. I think I got to check it at the diode block and see that I'm actually getting the positive voltage off the rectifier. I've traced it down, so I've got to trace a path that comes from this capacitor over to a relay. So if need be, I can put a wire in place of it if the trace is open. But let's just make sure that I actually have power coming off of the rectifier. Wouldn't that be something if the rectifier was shot? And I have 67 volts, so we know that we have power off the rectifier. It could be a severed trace between here and the capacitor, or between the capacitor and there's a relay over here. I've got the printout, right? And here's our capacitor. This is the foil trace looking from the top. So right now we've got our B plus right here. So that would go to this capacitor and then along here and ends up over here on this relay, which I have a negative voltage here. So somewhere between there and over here, it's broken. And it could be right where it passes underneath this negative capacitor, for that matter. It could be right under there, or a crack or a connection that's broken. But somewhere along here we are losing our B plus supply. I believe I can see the problem. If we look right down here, you'll see that there's a piece of rubber, like a rubber support, sitting on the board, right down there. And on that trace, that positive trace, if you look very, very carefully, it looks like that rubber has deteriorated. You can see a little black spot, and it looks like the rubber has actually deteriorated and burned through the trace going off the B plus filter. I'm going to stuff a wire in there and wire it right back to the main filter, to the rectifier. We'll see whether that restores the B plus. if I can avoid pulling this whole thing apart and taking all these boards out to fix this, I most certainly will, because this is a huge amount of work to pull this board to repair a severed trace. Here's where the trace comes up right here. I'm going to put a wire right from here and attach it back on the other side to the main filter on the other side. That's the idea anyway. That's why I had to get the layout for the board so that I could see where the traces went. So I was able to get a wire down to the positive terminal of the bridge rectifier, which is obviously connected to the main filter, to supply B plus to the amplifier. Let's see if it works. All right, I've got the unit plugged into the limited supply to see whether we get our B plus and our B minus. Our B plus should be here and our B minus on this side. Let's power it up. Okay, we've got B plus coming up and we've got B minus about the same. We're on the limited supply. So we got our power, we got our rails there. Let's give this thing full power and see whether it will actually start up. Plus 66 volts and our minus 66 volts. We've got no collector leakage. Why will the speaker protection not kick in? We've got our voltages back that we were missing before. Why will the speaker relay still not kick in? See, that was open. We fixed that problem. We've still got another problem on this unit. What the hell? If we look at the scope, we have output, but not very much. Well, actually, I shouldn't say that. I got output there. Speakers aren't cutting in though. That's weird. Right? I should have output. Speakers aren't turning on. Should be on now. Now if I plug into the main ends, that's to get the preamp going into it now. If I just plug into the main ends from my MP3 player, as you'll see, I got lots of output. So the amplifier is working, it's just that it's still in protection mode. And there's no reason that it's in protection mode. I think this might be the speaker. I'm just going to see if this is the output for this for the main speakers. So plug it back in. We'll just clip on and see whether that is the output relay for the main channel. Yeah, that is the output. That is the output right there. So why is the relay not energized? We'll just put the meter across the relay here. See if there's any voltage, which there's none. It's got 24 volts on both sides. It's not being commanded on, because one side would normally be grounded to turn on the relay. I bet you if I put a jumper wire across this relay, because there's no DC voltage on here, the amplifier is working. If I measure my DC voltage, there's like 0.1 volts. So if I put a jumper across this relay, I should have sound. Which I do. I have low sound. I could say mute. I know the preamp output is low because when I plugged my direct input into here, the scope was off the end of the scale. But coming off the preamp, it's low. So I guess we got to look into the preamp now and see what the hell's going on with the preamp. Power amp's working. That was a loss of voltage. Could very well be something else. And again, this thing was shipped too, so it could have been damaged during shipping. But where they glue these rubber supports on, a lot of times the rubber attacks the circuit board and deteriorates the trace, and I think that's what happened on the positive supply, because there's another one of these rubber supports which is right down in here, and you can see the trace is kind of black around there, which was this trace, wherever it was here, this trace here that went back to the filter capacitor. That trace is the one that went right back here to this filter. So what I did to make it, or to get voltage, was I just ran a jumper wire from the positive terminal of the rectifier bridge, because you can see it's connected to the capacitor, and then from there it went all the way over here and ended up over there. So I just put a jumper wire in place, and that restored my power to make the amplifier work. But now we're still stuck in protection mode. So there's another problem in addition to that. Got multiple problems with this unit. Plus the output from the preamp seems to be a little bit on the low side. So let's trace back to the preamp board. This has become a real 3-ring circus. I like to lift the board out to inspect under here, but to do that I've got to remove the tuner and a bunch of other stuff. So I have to unplug the tuner. It unplugs. Lift it out of the way. Remove a whole bunch of screws. Even at that, there's no room to remove the tuner, because even though it unplugs in one place, it doesn't unplug in other places. It unplugs from the board, and the shield lifts off of it, sort of. But it's hardwired down. Oh, that's just a zap tie. Let's just cut that out of the way. See if we can get this tuner out of the way here. Okay, get the tuner out of the way, sort of. And that way I can get this last screw. I think that's the last screw. And then possibly I can lift this board out and remove the main board, so I can inspect underneath it to look for other damage over here, because we know that the one power rail was already bad. So how does this lift out now? Just one thing after another with this. I think I have to remove this fuse holder, because I think there's probably, yeah, there's another board, another screw in the board down here. I think this has got all the board screws undone. There's probably a few more hiding. The whole board should slide back. I've got the heatsink undone. Got the board undone here. Got another screw out in the middle. Believe it or not, there's another fuse that's hidden way down in here. It's not blown or anything, but you can imagine if you have to replace that fuse, the work to get at it. Look at that, there's another fuse hidden right down there. Just trying to see why this board won't lift out. It should. I've got all the screws out. I think I've got all the screws out anyway, but it's not lifting out. Okay. Now it's starting to lift its way out. Lift that board out of the way. It ain't pretty. It ain't pretty. I want to just be able to look underneath the board. So if I can get this thing tilted out enough so I can see what's going on under here, then I'll be happy. Well, at least I can see now where the damage was to that trace right here, right under that rubber pad that's still here on the board. Here, I'll pull this out. You see? That rubber pad maybe got some moisture or something on it and just, or the rubber itself started to deteriorate and just ate away the trace. So I mean, I could certainly repair that trace right here, as opposed to the wire that I put in, even though the wire I put in is fine. It's never going to be a problem, but I could just repair that trace right there. Now that I've got the board out to this far on the unit so that I can inspect all these connections around the output relays and stuff, because I couldn't see them before. That's what I want to do, is inspect this thing. But there's where the damage was, right there. There you can see where the trace was open, caused by contact with this rubber, right? So that was part of the problem. I fixed that, but as I say, we still got the problem with the protection relay. So I'm just debating whether I should just put that wire over top of this. Maybe I'll take it off where I put it onto the top side and just bring it down here and solder it on down to the bottom here. I guess it really doesn't matter because it's doing the same thing. Since I had the board lifted, I figured I might as well just take this wire, the jumper wire that I had going up to the bridge rectifier on the top side, and I'll just bring it down on the bottom side of the board here to bridge over the section that's damaged right there. So we'll just bring that along here, and maybe just secure it in place or tape it in place or something. It won't go anywhere. But that way it gets it out of the way and repairs that damaged trace. Although that, I say I repaired it putting the jumper in on top, and I still had a unit that was stuck in a shutdown. Now it could have been leakage across this bit of crap that was still there, because there was obviously be leakage across here, or could be. So that may have been what was triggering the shutdown, because it was bridging between these two connections, right? So there may have been some leakage across there, and that may have been what was triggering the shutdown. I don't see any broken connections down here, so to speak. This is mostly just the standby power supply for the remote control. Looking at all the connections in here, I don't see any that are particularly bad. I did redo the regulator down here, but again, that's in the standby circuit, so I wouldn't expect that that's going to cause the system to go into speaker shutdown. What I did notice was that the preamp out seems to be relatively low. The power amp itself, when I give it a good signal, it puts out a lot of signal, but it was still in shutdown mode. So that's why we pulled the board to investigate. I don't really see anything that's problematic under here, so I'm going to reset this and put it back together and see if I get any different results. Now, to give you an idea how low the preamp output on this is, if I crank this unit up all the way, I've got the preamp output plugged into my other amp. That's full blast. I mean, this should be loud as anything. I've got the volume turned up quite loud on my receiver. To give you an idea, if I switch over to the tuner, so that's what I get off my tuner. Off the tuner on this, even with it cranked all the way up, there's the level difference. So the preamp output on this is very low. And it's not just the tuner, it's everything is low. That's the auxiliary input over here. So everything coming through this preamp, it's like it's in mute mode. Yet and also the amplifiers and protection, but there's no foreign voltage on the outputs. Like everything's looking good, it's just stuck in protection mode and mute. So it could be something up in the control circuit that's muting the output, keeping the output low, and keeping the unit in protection. If we look at the oscilloscope, here is the level of the signal at the volume control. Level of the signal looks okay, the volume control. Right? There's the input, there's the output, there's the wiper. Now, if I look at what's coming out of the preamp output at the back, it's much, much lower. So the signal's coming back off the volume control board, going back onto the main board, and then it is being muted before it even gets to the preamp output. If I crank my levels up here, you can see that there's our signal, right? There's our signal. If I turn the volume control up and down, you'll see that the signal goes up and down. Here is the signal level at the control by comparison. So somewhere between the volume control and the preamp output, our signal is being dumped. Here we go. Let's talk about stupid design. So I want to check this board down below here, which does not unplug. It is soldered down to the main board. So they've got this front channel board here mounted on top on the heatsink. The problem is I can't get a screwdriver in to undo the transistors from the heatsink to remove this board so that I can check below it. The only way I can get this out is I have to unsolder the transistors, remove the board, and then I can check the board underneath here. Stupid design. And I thought that Yamaha was bad, but now I'm starting to realize that this design was even worse. And I will never, ever, ever, as long as I live, work on another one of these units. I'm almost ready to throw the towel in on this one because it's been ongoing all day. I've got nothing else accomplished other than this unit. And as I say, if the fellow that shipped it to me had shipped it correctly and not put a high declared value on something that has clearly no value, I'm just, I don't want him to have wasted all of his money, but it's kind of looking like he's wasted around, I don't know, $400 getting this thing to me. $150 to ship it and another $240 in taxes that had to be paid. And I know someone who sees this is going to comment about how come there's taxes on it. Well, we have sales tax here. When you buy something, you pay sales tax, and that includes if you buy something from another country. As I've already explained, they don't know that I didn't buy this because the paperwork wasn't filled out correctly stating that it was a piece of equipment coming in for repair. And of course, that can't be changed. The only way he could have changed that would have been to have had it shipped back to him and pay the shipping back and then turn around and ship it back to me. So probably would have been further ahead just to have the thing shipped back to him and abandoned it. But we'll give it our best shot. See if I can find out why this unit is behaving the way that it is. I can't see it. There's no components that I can see that have failed on this unit. At least none of the ones I've checked so far. All the transistors are good. There is no DC voltage on the outputs or on any of them. So there's no reason why this thing is still in protection. But it is. And that's why I'm going to check out that driver board, which is below this one, which I cannot access unless I remove this board first. And then once it's removed, I can't power it. Well, I guess I could power it up without the transistors in. If you look at the time, it's now 11 o'clock at night. I stopped for dinner. The rest of the time has been spent on this unit. Okay, now with this board out of the way, I can now check this driver board. That cap there looks like the top is bulging, doesn't it? It sure does look like the top is bulging on that cap. See, what I don't know, and this is what I'm checking this for, is because when the plus 60 volts was lost, there was negative 60 volts appearing where there should have been a positive voltage, which would mean any capacitor that was in that circuit would have had a negative voltage applied where there should have been a positive voltage. So that could have blown out caps or any other parts that was expecting a positive voltage when it had a negative voltage due to losing the positive rail. So this is where we are, and what I'm trying to figure out what has gone wrong with this thing. But it's not an easy animal, this one, that's for sure. I'll just pull this cap out. I just want to check it. See, this cap looks to be bulging. Maybe I'm seeing things, but it just looks that way to me. This is a little 470 microfarad cap. But if you look at the top, that top looks like it's 470 at 16 would be 0.18, and this one's measuring up at 0.3, so it's a little bit up. The top does look, though, like it has, if we look at the top of this cap, it does look like that top is popped a little bit, doesn't it? Like the top's raised there. It looks that way to me. Let's look at it on the capacitor meter. So 470 microfarads. $64.1. I would say that one's bad. The other one likely is also bad. We'll pull this other one out here as well. It kind of looks like the top is a bit raised on this one too. So let's pull this one out. That's this guy right here. See what the value on this one looks like as far as what its capacity is. Oh, might help. Might help if I use the right. That's the leads from the ESR meter. Let's check this one out with the proper leads. 65 microfarads as well, and this is a 470. Let's grab a couple of new 470s, pop them in there and see if I get any different results. So here's a new one. Measure this one. Make sure my meter is actually working. Yeah, okay. So those two were bad for sure. So we'll pop these two new ones in. And fingers crossed, this thing's going to do more than what it has been doing, which has been nothing. And it was very likely that what happened was when that positive rail was lost, a negative voltage went across these caps and damaged them, more than likely. I just hope that nothing else was damaged. As having negative 60 volts appear where there was supposed to be positive 60 volts could certainly have damaged other components, for sure. But we'll start out simple. We'll start just changing these two. I'll just reconnect the center channel. If this doesn't do it, I don't know what to say on this one. It's about time I wash my hands. Even if I fix it, I've lost my shirt because there's no way I could charge enough for something like this for the amount of time that this shitty design has taken to get into and do any work. Yeah, nothing. Damn. I don't have speakers currently connected to it, but you know, it's not doing anything, so put it into dual speaker mode, like dual zone. A relay clicks, but that's just to put it into a dual zone mode. That's got nothing to do with the output. Well, I'm going to call it a night on this one. It's now 11:18 at night, and I've spent far too much time on this one. So I guess what I'm going to do at this point is I'm going to put this unit back together and get a hold of the guy that owns it and just let him know, you know, it's not something minor. It's certainly something that's major. It could be any number of components that have been damaged. It's certainly nothing simple. It's not connections, at least none that I could see. I've gone over all the ones that looked like they were questionable. I don't have any DC voltage on the output transistors, so there's no reason it's in protection mode, but it did have that negative 60 volts on the positive 60 volt rail due to that open trace on the main board over here in the power supply, which of course I've repaired. So that could have done any number of damage to any component. It could be something up here in the digital board, for that matter. It could be anywhere on here. Nothing's obvious why it's in protection mode. See, these two capacitors, they weren't shorted, but they certainly lost capacity, and you can see the tops were bulging, and that could very well have been because they had a reverse voltage applied to them when that fault was happening. But anyway, I spent way too much time on this today. I'm going to put this video up as a kind of a troubleshooting video, and I will get a hold of the guy that owns this thing and see what he wants to do at this point. It's certainly not worth fixing, that's for sure, but ultimately the guy that owns it has to decide what's going to happen with this. He's already spent a lot of money on this thing, you know, a lot of money in taxes which shouldn't have had to be paid, and then shipping. So anyway, thanks for watching. We'll catch you in the next one. Hopefully I'll have better luck tomorrow. Bye.